So here's an example on trig substitution. So the integral of x squared times the square root of, let's say, 25 minus x2 dx. X equals 5 sine theta, and so therefore dx is 5 times cos theta, 3 theta. So this, everybody agrees, a regular trig substitution because we recognize the pattern. Let's write our integral now. So x2, that's 25 sine squared theta times square root of 25 minus sine squared, the x squared, which is 25 sine squared theta, times dx, which is 5 cos theta d theta. Okay, let's simplify things a bit here. So I'll pull out the 25 and I'll pull out the 5, that's 125 outside. Integral of sine squared theta times, and here I could pull out a 25 and outside the root it becomes 5 square root of 1 minus sine squared theta and times cos theta. Any questions?
Hi, sir.
Yes.
Sorry. You just removed the 25 from inside the square root, right?
Yeah, exactly. It became 5 outside here.
Okay.
Okay.
Could you pull it out all the way outside of the integral?
Yeah, I will do now. I'll do it. I just didn't want to do it one step. So this is 5 times 125 is 625. Integral of sine squared theta times. Now 1 minus sine squared, we know that it's cos squared, and the square root is cos, and cos times cos is cos squared. This will be the integral that I have. Okay, any questions until here?
Can you slow down on that bunch of coses?
Excuse me?
Can you slow down on what you did on that step?
You want me to show you what I did here?
Yeah. So you changed 1 minus sine of theta into cos.
Exactly. 1 minus sine squared into cos squared.
Okay, and then you
Then
did the root,
exactly.
and then you multiplied it.
Cos by cos is cos squared. Exactly.
Okay, thank you.
Okay. Now I have to do this integral. Okay, so this we know what to do, right? We know this type of integral where you have sine power m, cos power n, and they're both even. Okay, if you remember, we use the identities. So sine squared is 1 minus cos 2 theta over 2, and cos squared is 1 plus cos 2 theta over 2 theta. This is what I have here. And then I could pull out a quarter, so 625 over 4, so C, yes, times, so 1 minus cos times 1 plus cos is 1 minus cos squared of 2 theta. Okay, any questions so far? Okay, and that is 1 minus cos squared. We know that it's sine squared. Okay, so I have 625 over 4 times the integral of sine squared of 2 theta d theta. Okay, any questions until here? Okay. Now I have again a sign with an even power. I have to use again the identity. So 625 over 4 times the integral. So sine squared is 1 minus cos of what?
4 theta.
Very good, thank you. 4 theta over 2 d theta. I pull out the 2 outside, so I have 625 over 8, and the integral of 1 is just theta minus the integral of cos for theta is what? You should know this by now.
Sine 4 theta over 2.
Over what?
Over 4. Over 4.
And that's it. My integral is done. The only thing I need now is to re-express everything in terms of x. Okay, so the headache here is that we have sine of 4 theta, but I need sine of theta. I need everything in terms of theta. Okay, because the argument in my substitution is theta, it's not 4 theta. Okay, so I'm going to rewrite again the two identities that you need for this. Okay, so I just hope I'm going to have space here. So a reminder again is that sine of 2 theta is 2 sine theta cos theta, and cos of 2 theta is cos squared theta minus sine squared theta. Okay, so you're going to use these identities a lot. Okay, these two. Okay, equals 625 over 8 times theta minus. Now, okay, so it's 1, okay, I'll do the over 4 after. So sine 4 theta is the same thing as sine of 2 times 2 theta. So I could use this identity and write it as 2 times sine 2 theta cos 2 theta. Of course, all this over 4. You understand what I just did?
Can you repeat, please?
Yeah. Okay. So sine 4 theta, okay, is exactly equal to sine of 2 times 2 theta. So I could use this identity here. And imagine instead of theta here, I had 2 theta. Right? So this would be 4 theta. And I would have here 2 sine 2 theta cos 2 theta.
Okay, thanks.
Should I repeat again? Anybody?
But sir, why don't we just like find the value of theta and just multiply it by 4? Like why do we have to use
Value of theta, like it's arc sine of x over 5.
yeah.
Because I don't want to have sine of 4 times arc sine. I don't want to see this.
Okay.
Okay. Okay. Once we got this step, then I could use sine 2 theta I replace by this, and cos 2 theta I replace by cos squared minus sine squared. Okay, so let's fix this here. So it's equal to 625 over 8 times theta minus, so 2 times, so sine 2 theta is 2 sine theta cos theta times cos 2 theta is cos squared theta minus sine squared theta, and all this over 4, and all this plus c. Are there any questions so far?
Yeah, sir, can you repeat what you just did?
What I just did, I just replaced sine 2 theta by 2 sine theta cos theta, and I replaced the cos 2 theta by cos squared theta minus sine squared theta. I just use these two identities. You good?
Yeah, thank you.
All right, at this point, I could simplify things here. So 2 times 2 is 4, over 4 disappears. Okay. And now I'm going to go back to my substitution, which is gonna run out of space. I feel it. Just save some space here. Everything I could get. Okay. So my substitution was sine theta is x over 5. Okay. Which means that theta is the arc sine of x over 5. And then I will draw my triangle, if you remember. So my triangles was like this. Theta. And the sine is the opposite over the hypotenuse, so x over 5. And therefore, the adjacent here will be, using Pythagoras theorem, 25 minus x2 square root of that. Okay, and so the cosine of theta is adjacent over hypotenuse, so the square root of 25 minus x2 over the hypotenuse, which is 5. Good? So now I have everything, sine theta, cos theta, I have everything in terms of x, and the theta is arc sine, and I could replace everything here.
Sorry, sir, could you replace how you got the cos theta? Like cos theta is equal to square root 25 minus.
This here, because look at this triangle. The cosine is the adjacent over the hypotenuse.
Oh, okay, thank you.
The adjacent we found thanks to Pythagoras theorem. Okay, so let's finish it off. So it's equal to, so 625 over 8 times. So theta is the arc sine of x over 5. Then minus, so sine theta, which is x over 5, times cos theta, which is root of 25 over x2 over 5, then times all this in brackets, cos squared, which is 25 minus x2 over 25, and minus sine squared, which is x2 over 25 plus. Okay, so this is my answer. I could simplify things further, okay, but I'm out of space. Okay, so this I could write 25 minus 2x2 over 25, and I could distribute this inside. Okay, I leave you the honors of simplifying it. Okay, I just don't have any more space on the board. The integral of, what did I write here? X over the square root of x2 minus 6x. Okay, so this is a tricky one. What do you suggest we do here? I have a big problem because I cannot do a substitution, right? If you take u as x2 minus 6x and you derive, you will get 2x minus 6, which just does not match with what you have on top. So no substitution here. if you want to do a trig substitution, you will do, you don't have, you have A2 minus U2 minus A2. So this cannot be an A2 because there's an X. So you're stuck. So I don't recognize any of the forms here.
Sir?
Yeah.
Can't we use x squared as u?
No, because then A2, A squared will be 6X.
No, I mean like u substitution, not trig substitution.
Oh, okay. And then what? X2 as U?
Yeah, and the derivative of u would be 2x dx.
Perfect. So you'll have, okay, so the top will work, but on the bottom, what will you have? You will have the square root of U minus 6 root U.
Yeah,
Maybe it's going to work. I don't know. U minus root of, I don't know, minus 6 root X, root U. Maybe you could survive with this, but I think it's going to be complicated.
Could you like isolate x in the bottom? Like make it x.
Factor it out.
Yeah.
I don't know. And then what? X times X minus 6. And then what?
Like trig substitution.
I need to recognize U2 minus A2.
Sir, can we like complete the square?
Oh, that's very good. Okay, so complete the square is very good. If you complete the square on the bottom, because this looks like the beginning of a perfect square, if you complete the square, then you might express this as a difference of squares and do a trig substitution. This is going to work.
Could we, like, instead of completing the square, because I don't know how to do that, or like I forgot, rather, could we square everything so that we get rid of the square root?
No, you cannot. You cannot square. Square the top, square the bottom, square everything.
Yeah.
No, you can't. The integral of the square of x2 is not the same integral as x. You can't square. You're not allowed to do that. Okay, so top stays. And so let me complete the square. X2 minus 6x. And at this point here, I'm going to add something and minus something. What do I add? What do I minus? So you take the negative 6 divided by 2 and square it. Divided by 2 is 3. 3 squared is 9. So that's what I'm adding. I'm adding 9. I'm minusing.
Sorry, how did you get the 9s?
The 9 is, I did this to here. I did negative 6. So I divided by 2. And then I squared it.
Okay.
Okay, so here we're just completing the square. Okay, so you probably did this in high school when you were studying conic sections, right? Right, the cones and not the cone, the ellipse and the hyperbola, parabola, and all this. Okay, and circles. Okay, so at this point, and I'm gonna let you finish it, but I'm just gonna set it up here. Square x over the square root. Now this is a perfect square, which I can factor as x minus 3 squared minus 9. X. Do you understand this? Okay, and now I recognize my trig substitution. So x minus 3 will be 3 sine, 3 secant theta, right? Secant. So my substitution here will be u, which is x minus 3, is equal to a secant theta, so 3 times secant theta, and so dx is derivative of secant is secant tangent. 3 secant theta tangent theta d theta. Okay, let's rewrite our integral. There's space here, just don't do it. So it's the integral of, so x, what's x? If I send it 3 on the right, so it's 3 plus 3 secant theta, that's x. Over, on the bottom I have the square root. X minus 3 squared, so it's 9 secant squared. Minus 9 times dx, which is 3 secant theta tangent theta. Not very clear. Okay, we continue here. So what do I have on top? So I could pull out a 3 from here and a 3 from there, so it's 9 times 1 plus secant theta times secant theta tangent theta d theta, and on the bottom, what do I have? So square root of, so I could pull out a 9, becomes 3 square root of secant squared theta minus 1.
Sir,
Yeah,
can you repeat how you pulled out a 9 like on the numerator?
yeah, I pulled out the 3 from 3 plus 3 secant. I pull out a 3 from here, out, and times the 3 that was there, this 3, it becomes 9.
Okay, thank you.
Okay. Are you guys okay if I cross out this square root with the tangent? Understand?
Nope.
No?
Why would we do that?
I'll do the step. So 9 over 3 is just 3. Then on top I have 1 plus secant theta times secant theta times tangent theta d theta. And on the bottom here, I have the square roots. So secant squared minus 1 is tangent squared.
That's one of the identities, right?
Yeah, this, you have to know them, like, no hesitation. Okay, so just here, this is from 1 plus tan squared theta is equal to secant squared theta. Okay, I should eventually maybe redraw the unit circle and show you all the identities in the circle. Maybe you'll visualize it if you have an image in your head. Okay, so maybe a review of trigonometry would be good. So tangent squared square root, this is tangent, and this crosses out with this tangent. Okay, so far? So I'm left with 3 integral of, so secant plus secant times secant is secant squared d theta. And we could integrate this very easily. The antiderivative of secant, we learned, we did it, we proved that it's ln of secant plus tangent. This is done. Sorry. And the antiderivative of secant squared is tangent. Okay, so the integrating part is done. We just finished integrating. Okay, so just one thing left is to re-express everything in terms of x. So I have to go back to my substitution. Okay, let me just finish it and then I'm going to take questions. So secant theta is x minus 3 over 3. But secant, we know it's 1 over cos. So 1 over cos theta is x minus 3 over 3. And so if I flip everything, so cos theta is 3 over x minus 3. Okay, I could now draw my triangle. Cos is adjacent over hypotenuse. So the adjacent is here, and the hypotenuse is here. Sorry, the adjacent is 3. Adjacent over hypotenuse. So adjacent is 3, and the hypotenuse is x minus 3. Okay, and if you do Pythagoras here, hypotenuse squared minus this side squared square root, you will get, okay, so I'm going to simplify it right here. So you get x minus 3 squared minus 9, which is exactly what we have here, which is actually x2 minus 6x. Square root of x2 minus 6x. That's what you get if you do this squared minus that squared. Okay, and so from here, I could find what the tangent is. Tangent is opposite over adjacent. So square root of x2 minus 6x over adjacent, which is 3. And now I just need to replace out everything in it. Okay, so equals to 3 times ln of absolute value of secant, which is x minus 3 over 3, plus tangent, which is square root of x2 minus 6x over 3, plus tangent. So I distributed the 3, so 3 times tangent, which is this guy, square root of x2 minus 6x over 3 plus. And that's it. I'm done. I can cross out the 3's and